the currents that I'm interested in occur a long way out. They occur 19 Earth radii out into the tail region, which is, if you have the Sun and then the Earth, the tail is the region that follows. However, some of the aurora can be created lower down, much closer to the Earth, in an auroral acceleration region, which might be closer than 4 RE in, maybe even 1 RE above the Earth's surface. So some of them can be close in, some of them can be further out. And the ones that I've been looking at with cluster have been the ones that have been much further out. There are charged particles in the magnetosphere. The magnetosphere is made up of plasma, and plasma is ions and electrons. So neutral particles are split up into ions and electrons. The electrons orbit the positively charged nucleus, and in a plasma, these two bits get split up. So you have the negative electrons and the positive neutral ions. And most of the time we think the current is probably carried by electrons. The electrons are that much smaller than the ions. You're talking 2,000 times less mass in the electrons, but roughly equal charges. So these electrons can be moved around much more easily than the ions can. So the electrons that are free to move can cause these current systems. So the northern lights, or the southern lights, what we call the aurora, are caused by the particles in the magnetosphere streaming down the magnetic field lines. So streaming along those field lines that cause your compass to turn. And they stream out of the magnetosphere, where it's fairly sparse, there's not a lot there, and then they come down towards the atmosphere and encounter a charged layer that we call the ionosphere. And when they reach that layer, they start colliding with all the particles in there, exchanging charges, and this exchange allows light to be emitted by the particles that are in the ionosphere. So these electrons come streaming down, collide with the particles that are there, and that then causes an emission of light, what we call the aurora.